Okay, now we're looking at tangents and the circle theorems that apply to tangents. Now, there are 3 circle theorems that apply to tangents, and these are the last circle theorems that we'll look at. But first of all, we must understand what a tangent is. If I have a circle like this, and I have a straight line that passes by, making contact with the circumference, but not cutting into the circle, right? This line here is just kissing the circle as it passes by. It just touches the circumference but does not cut into the circle. So that's what we call a tangent, right? So a tangent just makes external contact with the circle. So this is what we call a tangent. Now that we understand what a tangent is, let's go through the tangent theorems, just 3 theorems. So there's theorem 1. Theorem 1 states that angle formed between tangent and radius at the point of contact is 90 degrees. So angle formed between tangent and radius at the point of contact is 90 degrees, right? So now let's see what that looks like. If I have a circle, and then I have the center and I have a radius coming from the center there, then I have a tangent that comes, meets with the circle as it passes by. So I have a tangent there, and then I have a radius there. These two are meeting here, right? Where they meet, they form an angle of 90 degrees on this side and also on the other side. So if a radius and a tangent meet, they form an angle of 90 degrees. So when you are looking at your circle geometry questions, when you come across a tangent, make sure you check if it's meeting with a radius. If it's meeting with a radius, then you understand that the angle between the tangent and the radius is 90 degrees. Let's proceed to our second theorem for the tangents. Theorem 2 for the tangents. If I have a circle again, and then in this case I do not have a radius, instead I have a chord, and then I have a tangent. So in this case my tangent is meeting with a chord. In theorem 1, my tangent was meeting with a radius. In theorem 2, my tangent is meeting with a chord. And when they meet, they form an angle between them. So there's an angle between the tangent and the chord, right? And we're going to call that angle x. So the tangent and chord are forming angle x. If the chord itself subtends, in other words, creates an angle on the other side, that angle will also be x. So what does this mean? It means angle formed between tangent and chord, this one, is equal to angle subtended by the chord, that one. So that's our theorem 2. Angle formed between tangent and chord at the point of contact is equal to angle subtended by chord in the other segment. So if you come back here, you realize the chord forms two segments, the one on this side and the one on the other side. The first angle was in this segment, the other angle is in the other segment there. So you might need to look at this 2 or 3 times and make sure you understand what this means. Let's go to the last theorem, and the topic on circle geometry is over. So Theorem 3 on tangents. If I have a circle and then I have a point outside the circle, I can draw 2 tangents from that point touching the circle. There's the first tangent and there's the second tangent. Call the first tangent T1, the second tangent T2. What you need to know is that tangents from an external point to a circle are equal in length. So the length of T1 is equal to the length of T2. The length of T1 is equal to the length of T2, and we can put that in writing and say tangents from an external point to a circle are equal in length. So that does it for the theorems. Those are the circle theorems. Those should be enough for your syllabus. Those should be enough to take you through all the questions.